Hey there, Algebra 1. We're going to continue with Chapter 8. Got a couple of review questions here to get started. Should be a nice, simple review. No exponents on the outside, so multiply by get 10. And remember, for multiplying, I'm going to add these exponents, get x to the 6th. And y, this one counts as 1, so y to the 5th. No big deal. These are both going to be squared first. So we have to take care of a little bit of pre-work before we can do anything else. 9x to the 4th, power to power, y to the 6th. 25x squared y to the 6th. And now it looks just like the problem before. But if you had 9 quarters, 4 quarters and $1, so that's 225. And we got x to the 6th, and y is going to add up. I get 6 here and 6 here, that's 12. All right, so it's getting some of those exponent rules, because we're going to do those today when multiplying with variables. We need to add the exponents. Okay, so as we look here, we're going to use distributive property and our exponent rules. We're not going to do anything new at all. We're just going to kind of put it together, and then we're going to do everything in reverse, right? That's called factoring. We're going to factor things out. So 35n minus 10, that's all we have to do. Since that's all we have to do, I made sure I threw in some fractions here. So remember, this is over 1 and over 1. So we kind of show it that way. And what we'll also show you is you want to reduce those prior to doing anything else. So that's 2 over 1. So we're all set there. So that's going to be 6. A times a is a squared. Don't let that get lost in the whole thing. And again, this goes back to 4 when I go to the second one. So 12 divided by 4 is 3. So 3 times 3 is 9. And it has an a. It was positive times a positive, so it stays positive. So distributing, what's 3/4 of 8? It's 6, and 3/4 of 12 is 9. All right, in the next one, no fractions this time, so 6 times 1 is 6. R times r squared is r to the 3rd. S times s is s squared. Minus 6 times 3 is 18. The sign's going to be negative. And r and s don't get anything extra given to them, right? Just distributing. It's kind of fun. All right, so 4 times 3, that's 12. T squared and t squared, that's t to the 4th. 4 times 2 is 8. And they were both positive, so I'll keep it plus. T squared, another one, is t cubed. And then 4 times negative 5 is negative 20. T squared doesn't get any more, so it stays t squared. Easy peasy. All right, this time we're going to distribute a negative, so be careful with that. Negative times a negative is positive. So 4 times 3 is 12, and we'll get m to the 4th. Next, we'll do a negative times a negative is positive. This time I do have to show the sign. 4 times 6 is 24. I get m cubed and an n. And they're not the same base, so I can't add those together. Negative and a positive is negative. 4 times 4 is 16. M cubed. P wraps that one up. All right, so what we had to get started way back here, right, this distributing type of thing, multiplying, all we're really doing is doing that over and over again, since we now have some polynomials, right? These are all monomials multiplied by some form of a polynomial. All right, so here we got negative 1/3, right? X over 3. So instead of thinking about multiplying, think about dividing by 3, because we have a 1 here. So just 27 divided by 3, that's going to be 9. Negative and positive is negative. So we get x to the 3rd power. Ooh, that 3 doesn't look so good. That's better. All right, 6 divided by 3, well, that's 2. It was a negative and negative, so I'll make it positive. And x times x is x squared. All right, 12 divided by 3, well, that's going to be 4. It's a negative times a positive, so it's negative. And it doesn't carry any more x's. We'll just make it x to the 1st power. All right, so here's what you might see in some standardized testing. So you kind of go through term by term and see what we have to do here. So the first thing we're going to do is know that the first term should be negative. So I know these are still in play. I'm going to get rid of this one because that's just not right. The next thing you notice is just I should have x squared and y to the 5th. X squared, y to the 5th. All right, so we just got rid of b. Right, but that means that I need to start working on the second term because both of these have the same first term. And one thing I want to teach you as we go through this is the second term is exactly the same in both a and c. So I really shouldn't spend my time on this, especially if it's a time test and you get up to the SATs. We don't want to do that. So what I'm looking for is the last one. I do notice that it should be -6 in both of them. And now I start to see and notice a difference here. So that one is x cubed, one's x squared. So what am I going to get? X squared and another one, it has to be x cubed. So my answer is A. So a lot of little details, signs, but you want to start to eliminate some choices and narrow down to what the difference really is. All right, so now we're going to work in reverse. We want to find the greatest common factor. All right, so greatest common factor. So circle the pair of numbers with a GCF of 4. Well, 5 is not divisible by 4, so that's no good. Same thing with 6. What about 8 and 12? Okay, well, there's, 2, 4. They're both divisible by 4, so they work by 4. What about 8 and 16? Well, this one happens to be 8 instead of that. Okay, so 8 and 12. What about 4x? Well, it still has to have the GCF 4, so I'm going to get rid of some of these. And this one's going to be 8x, so that's no good. So it happens to be the same. Now, why is it a common factor? Because they both have an x. So that's how that works. Cross out the pair of numbers whose GCF is not 6. All right. Well, 15 is not divisible by 6, so that's not going to happen. Same thing with 16. That's not going to happen. 24 and 36. Now they're both divisible by 6, but I think they're divisible by a little bit more than that. Right, I could go the whole way to 12 here. Okay, so I'm going to get rid of that one. So I do find my solution here. Now notice all the numbers are the same, except for this time we have y squared tacked onto it. And what that means is that both of the terms have to have at least y squared. Okay, so that's we find out what a GCF with variables. So this typically is the new thing from 8th grade to your Algebra 1. All right, so 14, 1, 14, 2, and 7. I don't think there's anything else, but this n squared is n times n. 35, 1 and 35, 5 and 7. Okay, so we're trying to find n times n times n times n. All right, so we're trying to find the greatest common. Well, 1's common, but then 7's common. So the greatest one is 7. Well, what I also notice is they both have at least 2 n's, so that's n squared. Okay, so notice what I said there. They both have at least 2, right? If it's n squared and n to the 4th, they both have at least 2. So n squared becomes the GCF. Okay, so out of 21 and 18, right, we could list out all the factors. But my hope is that by now you know the GCF numerically is 3. So our focus here is they both have at least how many? They both have n cubed and n squared. So I'm looking for, it's kind of a play on the mind here. You're looking for the most that they both have. So I'm looking for the smallest number. So they both have 2. So my GCF is 3n squared. And what about 7n squared and 9? Well, I noticed that 7 and 9, I don't have a GCF. Oh, wait, there's always a GCF, and that's 1. Now, I don't have any n's on 9, so it's just 1. Right, now, finding the GCF is kind of important to what we're going to do next, because all the time that we were putting these things into the problem, right, that was distributing. Well, factoring is when we take all the things out of the problem. So we're going to find the GCF, and then we're going to take it out. Okay, so first of all, 3, 9, and 12 are both divisible by 3. And then I'm going to focus my attention on the variables x to the 4th, x squared, and x to the 1st power. So how many do they all have at least? Well, this has 4, this has 2, and this has 1. So that means the most that they all have is 1, right? Because 12x only has 1, so that's all I could do with it. All right, so that's the first thing is, what is the GCF? If that's what it says, that's all I have to do. If it says, what is the factored form? Now I'm going to find the GCF, 9, 15, and 12, all divisible by 3. Then I focus my attention, x to the 6th, x to the 4th, and x squared. Well, now what I notice is they all have at least x squared. So we're going to divide each term by 3x squared and list my GCF out front. But 9 divided by 3 is 3. X cubed, x to the 6th divided by x squared is x to the 4th. Plus 15 divided by 3 is 5. X squared, right? X to the 4th, divide out 2 of them. Plus 4, x squared divided by x squared, that's all we got. Okay, so a very different, a very subtle change, but a very different answer. Not just find the GCF, but we're going to find the GCF and then also give the result of what is left. Okay, and that's what we're going to work on here. So we're going to factor each one. So 13 and 39, guess what? They're both divisible by 13. I see c to the first power and c to the second power, so c to the first works. D to the third and d squared, so that means they both have at least 2. So what's left? Well, out of the first one, 13 divided by 13 is 1. C divides out the c. D to the third divides out 2 of them, so d plus 39 divided by 13 is 3. C squared, take out 1. D squared, take out both. So there we have it. Now, what are these two lessons? It seems like two separate lessons go together. How do I check? If I distribute this back in, I should get what we started with. Okay. All right, 36. Let's take a look at the next one. 5 and 25, both divisible by 5. X cubed and x to the first. So I only have 1 in both of them. Y to the fourth and y squared, that's 2 of them. So if I take out the 5, it's going to give me 1. X cubed, take out 1, so I have squared. Y to the fourth, take out 2, that's y squared, minus 5, because 25 divided by 5 is 5. Take out the x, take out 2 of the y's, that's all we got. How do I check it? I can mentally or physically go ahead and distribute that. All right, I know what you're thinking. You're like, oh yeah, you've been doing this a lot, so you kind of know about factors. Like we talk about all sorts of different numbers because it's math class, you know what I mean? What if I'm not sure what it is? All right, so let's take a guess. What do you think's going on here? 42 and 28. Well, I get a lot of kids that are like, well, they're both even, so let's at least divide it by 2. All right, so let's do that, and then we'll see what happens. But I can also take care of m to the fifth and m to the fourth. They both have at least 4 of them. Well, that was crazy. All right, so 42 divided by 2 is 21. I'm going to get down to mn plus, we have 28 divided by 2. Well, that's 14, and I took out all 4 of those m's out. And like, oh my goodness, I can't believe I didn't see this before. 21 and 14 are both divisible by what? 7. So what I have to do is I have to take the 7 out of here. Right? So as I take the 7 out, I'm going to list it out in front. So that means it's going to be 14m to the fourth. Okay. But as I'm doing this, remember I took out a 7. So divided by 7 is 3mn plus 14 divided by that 7 is 2. So it's not that I did anything wrong by taking out just 2m to the fourth. It's that it didn't have the greatest common factor yet. And there's nothing wrong with that as long as you realize that you still have to take out, divide out that 7. Ooh, that was a bad color combination. Man, there we go. So if I divide out the 7 as well, and then put these together by multiplication. Okay, so you can step your way into finding that greatest common factor. Okay, so no wasted time there. All right, the next 3, kind of the same idea. You want to give those a try. That way this video doesn't go on too long. So I'm going to find those. Okay, and then just a quick hit here. Identify just the GCF, because remember, those are the 2 separate things that we'll deal with. All right, we'll deal with these in class the next time we're together, and then you'll see some homework down below. We'll put a little more space in here, that way you have it if you're in my class. If not, hey, thanks for tuning in, and I hope you got something good out of it.